All right, here's the video on that is going to introduce the chapter probability. And before we get started, we actually need to review some of the concepts we've seen in the past. Okay, so one of them is when we deal with in the chapter probability, we're drawing a lot from the previous chapter, the counting methods chapter. Okay, so permutations, combinations are going to come with us, except for now we will have we will deal with probabilities, probability versus odds. Okay, so that is one thing that we will review in a bit. But probability, in a sense, okay, when we're putting it together, we will say that probability of an event happening is we're going to figure out the number of events, right, that are preferred events that we're trying to accomplish. So it could be like raining or drawing a red card or you name it, divided by the total possible ways, right? The universal. So probability, in a sense, is preferred outcomes over total. Okay, and it can be stated as a decimal, right? You can state it as a decimal, as a fraction, as a percentage, or in words, right? But I'm not going to talk about that here. But three mathematical ways of doing that. Remember that the maximum for probability, maximum is 1 or 100%. Okay, so that's the maximum we can possibly have on probability. There's no such thing as 120% chances of rain tomorrow. You can talk about 120% increase in price, that yes, but when it comes to probability, maximum is 100. Think of it as, this is important for this chapter in particular, I think of a pie chart, okay? And that is 100%. If you're talking percentage, then that would be 100%. If we're talking decimals, so it would just be 1. But if there's a probability of something happening and that's 40%, like let's say that's A happening, then not A would be 60%, okay? So A happening is 40, not happening is 60%. So that's kind of like the idea. We're going to use that a lot, okay? And another thing is that probability always wants the total possible options in the denominator. Odds, on the other hand, we do not care about the total. Okay, do not worry about the total. What we want is, there are two different ways to state odds. Odds for or in favor. Then you want the event happening. So let's say drawing a red marble. And the event not happening. And the way I'm going to state it is, I'm going to use the notation we should be familiar with: event happening, event not happening. And the other way to state your odds would be against. When it's odds against, then you want all the events, all the occasions where that event is not happening, comes first. And then the event happening, the number of instances where it happens, comes next. So this is a little bit of an overview. No total though. You're never going to have, the probability of drawing a marble is 2 out of 10. It would not be 2 and 10. It'd be 2 and 8. Okay? Because if there's 2 red marbles out of 10, then there's 2 instances where you would get a red. Okay? And 8 instances where you would not get a red. So that's how odds is different. Okay? And so we'll actually use a blank page in our booklet. I have a few pages here that review the same concepts that I'm going to be talking about. I'm going to be summarizing it all on page 4. But the first thing here is, if we go to page 3, is making sure that when we have fractions, and turning them into a decimal turns into an infinite decimal, a repeating decimal. So 1/3, for example, right, just keeps on going. So I always want you to remember that when you divide that to get a decimal, okay, that you go to your screen, okay, and from here, for example, you would round to 2 decimals in this case, so 0.33, okay. If, on the other hand, you wanted to state 1/3 as a percentage, you don't just multiply this by 100 and get 33%. That would be rounded incorrectly. You would take whatever's on your screen and multiply that by 100, and now round your answer to 2 decimals. That's how you round correctly. Words would be 1/3. So a fraction is one way of stating it, decimal percentage words. And so that's something to remember. If it's a finite, 3/4 is 0.75. If you divide it, no problem. You just 0.75 as a decimal, 75% as a percentage. But remember, I technically always want you to go back to your screen and state that. This would be 3/4. So that's just a simple review of previous concepts that you should already know. If you want, this is probably a good one to have on your study sheet. Probability of an event is the number of favorable outcomes divided by total possible outcomes. Okay, so that's a good one to have on your study sheet. It's always one thing to make sure. Maybe I should add that now because it happens all too often. Numerator is always less than denominator. If you have it the other way around, if you do the math and the bottom is smaller than the top, you have a problem. It's impossible to do that. Okay, and probability, you could have the top and bottom the same. That would be 100% chance of something occurring, but it's very rare. Another way of stating probability, the probability of something happening is number of events that it happens over the universal total. And then on the other hand is probability of something not happening is the number of instances where it's not happening over the universal. Okay. One thing that I do want you to understand is that I'm going to use 2 different colors here. Highlight NA is it happening, and not A is a different color, right? So then you make sure you understand that. And the most common way to get not A, I don't know if you remember that from chapter 3, not A is taking the universal and subtracting all the elements that are in A away from the universal. That's how you get the not. Okay, so I will actually take the same color and highlight that. So for example, if there's a 2 and 10, right, 2 out of 10 ways to pick a red marble in a bag, then this would be 8 out of 10, correct? And the reason you know that is because you went 10 minus the 2 red ones. That's what gave you 8, okay? Another thing is when you're comparing like sometimes you'll be given odds or probability, and when you're comparing which one is more likely to happen, make sure you turn it into a probability and get it into a decimal, and then you'll be able to tell which one is the most likely to happen. It's the highest probability of something happening. Next. Here's where I'm going to summarize what you need to know in order to complete the rest of the pages all the way to 11. So probability max is 100%. Total in denominator. So remember that. I will say that probability, I will repeat some of the stuff I already said. Probability of the event is the event over total. Number of events, let's do that. Number of events that you're looking for over total. And probability of the event not happening. And watch what I'm going to do here. I'm going to give this a little spin here. I go total minus event over total. That's the most common way of doing that. Number of events. I will do this. Number of events. So we go total minus number of events over total. So that's basically the probability of something happening and not happening can be found out this way. And remember, if I tell you either one of those, if I tell you the probability of something happening, you can right away determine the probability of it not happening. For example, I'll give you an example. I think that's the best way we learn. Example, probability of drawing a red marble. Let's say I give you it's 7 out of 10. Okay. You should immediately know that probability of not getting a red, you have all the information here of figuring out the probability of it not happening. Basically, you can tell that it's going to be 3 out of 10 just by looking at this. But sometimes the numbers are going to be really big. So we're going to go 10 minus 7 over 10. Okay? So that'd be 3 out of 10. Another way could have been is that you realize, oh, well, probability of red is 7 divided by 10 is 0.7. So probability of not red could have also been found by just going 1 minus 0.7. You don't need a denominator here. That would have been 0.3, which is also 3 over 10. Same thing. So this is the relationship I want you to be very familiar with. When it's a fraction, it's just a little complicated, a little bit more work, right? You go 10 minus 7 to get the top, right, to get the 3, but the denominator stays exactly the same. That doesn't change, okay? When it comes to odds, okay, odds, you don't never include total. Never include total. You're going to be able to find out, but it shouldn't be in the odds per se. Okay, so when it's odds, you have in favor. Okay, 4 in favor. Right. So sometimes it says the odds for of something happening is another way. Right. That means in favor. All of these variations mean in favor, or odds of winning, that's in favor, if it's just of. And then the other option is against. Not happening. Okay, that's the other option. So every time there's odds mentioned, it should follow by either an indication that this is in favor, odds in favor, or odds against, okay? So keep that in mind. So when it says 4, when it says in favor of 4, we would want event, number of events happening, compared to number of events with a little bar on top. Okay. So that's what we want. We want to compare how many times is it happening, how many times is it not happening. So it's in this format. So I will use just a letter here. So in a sense, it's A happening versus A not happening. And the order matters here, meaning that if it's 4, then the number of events it happening goes first, and then it not happening goes second. When it's against, it's number of events where it's not happening, that comes first, versus number of events happening. Okay, so it's in this order that you have it there. So really, you would flip it. You would have how many instances is it not happening? How many instances is it happening? Okay, so I will use my previous answers here. What if it says odds? This is an example. Odds in favor of red, of drawing a red marble, right? Of the spinner landing on red, of drawing a red card, you name it. And how about this? Odds in favor of a red marble. We're just going to use the example above. So that means that you would want all the instances where you do get a red one, all the possibilities for drawing a red goes first, and everything that isn't red will go second. Okay, that's how you state your odds. So if your probability of red, let's do that on the side here, remind ourselves, was 7 out of 10. Okay, 7 out of 10. We know that because it's written like this, is that the 7 represents the number of red marbles. So we would go 7. And how about not red? How would you find not red? You go 10 minus 7, right? You go 3. I went 10 minus 7 to get that number there. So these would be the odds in favor of drawing a red marble. And if it says against, in this case, because we do have the odds in favor already, all we would have to do is flip them. 3 to 7, like that. That's the exact opposite order. So sorry, I should have done that. Not red goes first, and then red goes next. Okay, so that's one thing to remember. That's how you distinguish odds from probability. And remember, you can do a check, right? We know that our total should be 10, and you can verify that by saying, hey, yeah, both numbers add up to the total, which was given by the probability. And maybe let's write on this side here, we knew that the probability of not getting a red one, we already knew that it was 3 over 10 from the example above. So I basically used 3. I knew that this represented not reds, right? Everything that isn't red. And how did I get 7? I basically went 10 minus 3 to get that 7, right? So that's one thing to remember. Okay, let's do some examples here. Let's do the, on page 5 here, practice, state the probability. So we're just going to stick to probabilities first. Of the following as a percentage when rolling. A 6-sided die. So probability of rolling a 2, there's just 1 out of 6. I'll just go fraction for now. This would be 0.16, and it keeps going, so technically 0.17. This would be 16.67 if you rounded it to 2 decimals as a percentage. Because remember, this is 1 over 6 is 0.166, it keeps going, okay? So that's, I look at my screen and I round it to 2 decimals to get this. Then I go back to my screen, multiply that by 100 to get this one, okay? Probability of even from 1 to 6, there's just 3 options out of 6, right? That is 1/2, that's 0.5, or 50%. Divisible by 3, it'll be 3 and 6. So that's 2 over 6, which is 1/3, which is 0.33, and that's 33.33%. If you want to pause it and give it a try, you just go ahead and try this first. Prime, what is our prime numbers, right? 2, 3, 5, 7, 11, and so forth. So just be these 3 numbers here, right? So 3 out of 6, I'm just going to leave it like that for now. Less than 5, less than 5. So it'd be 4, 3, 2, 1, right? So it'd be 4 out of 6 options. That's 2/3. Don't worry so much about reducing fractions. I'm not going to give you marks for it. 0.67 as a decimal, but 66.67% as a percentage. Remember, you go back to your screen. Greater than 6, that's 0 out of 6, right? There's no such thing, 0%. Greater or equal to 3. So that would be 3, 4, 5, 6. So there's 4 out of 6, which is 2/3. We know already that that's going to be as a decimal in percent. Let's try here. Deck of cards. Remember, we've got 26 red, 26 black. But by the red, you've got diamonds, hearts, and you've got spades and clubs. Okay. So there's 13 of each. And you've got ace, 2 to 10, jack, queen, king. Okay, so that's a bit of the tree just to review. So probability of drawing an ace. Remember, we've got 52. Probability, we want the total. An ace, there are 4 aces. So that'd be 4 out of 52. Probability of a club. Clubs, 13. 13 out of 52 would give you a club. And if you reduce it, if you think about it, it's a quarter of your entire deck, right? Because each suit has 13, so this reduces to a quarter. You can check, divide them, you get 0.25 or 25%. Ace of club. Ace of club, very specific. 52 cards still. Ace of club. If these are my clubs here, I might be mixing up spades and clubs, but it doesn't really matter. There's just one ace of club, just one, okay? And that'll be a very small decimal, right? Like if you go 1 divided by 52, you get this. So if you round it to, I'm going to give you a little trick. It's okay to round to more than 2 decimals. So if you wanted to do 4 decimals, 0.0192, and if you want to just multiply that by 100 and get your percentage, that's fine, okay? Greater than 6, how would we do this one? Still 52. Let's do a little bit of adding up here, or figuring out what are we talking about. Greater than 6 would be, if you think about it, would be 6, 7, or greater than 6, so we can't include 6, 7, 8, 9, 10, jack, queen, king. So 1, 2, 3, 4, 5, 6, 7 times 4. So that's 28. 28 of those in this deck. Red queen. There are 2 red queens, right? Hearts and diamonds, they both have a red queen, so there's 2 out of 52. Red, that's just 26 out of 52. That's a half, right? Not face card. How do you do that one? Not face card. I want you to be okay with that. It's basically saying probability of face not. I'm going to do this. I know there's 52 in total. Not. Mr. Erickson told me, go 52 minus, there are 12 face cards. Jack, queen, king, times 4. There's 12 of them. So you end up with 40 out of 52. That's how you do that one. Picking a jack. There's 4 out of 52. Not jack. Go 52 minus 4 over 52. So that's 48 out of 52. Okay? How else could you have done that? You know, probability of jack is 4 out of 52. Let's figure out what that is as a decimal. You go 1 minus that. It's, if you multiply that by 100, it's 92.31%. Let's check what 48 divided by 52 is. The same thing, right? If you multiply that by 100, you get the same thing, 92.31. Okay, so there's a lot of ways to do that. Red face card, there are 12 face, half of them are red, so 6 over 52. Okay, so that's that. Let's skip to page 8. And then I'll ask you to do everything to 11 from here. I'll post a video that goes over it. What's my time here? I will stop here. If you need more help, I'll finish 8, otherwise I'm going to go, it's going to be too short of a video. But look at this, odds of being struck by lightning is 1 to 11,999. Because it's worded like this, that means that the first number represents being struck by lightning, and the other one is, what's the opposite of that? Not being struck by lightning. Okay, immediately, just with the wording, you can tell that the first number is the event, right? Lightning is the event. It happening, it not happening, because of the way it's worded. If it had said against, then this first number would have been not being hit, the second one would have been the one being hit. State the probability against being struck by lightning. Probably against. Basically what they're asking you is, what is this? Well, I know that not being hit is 11,999 from here. What is the bottom here? It's adding these two up. That's what gives you the total. Okay, so it's 11,999 over 12,000. Okay, that's how you do the probability there. What are the, state the odds against being struck by lightning. Since you already have the odds, just flip it. Just flip original. Okay? So it's 11,999 to 1. That's it. Out of 850,000 people, how many are likely to be struck by lightning? How many are likely to be struck by lightning? This is a bit of a prediction you make using the probability. The probability of being struck by lightning is 1, right? Just 1 time out of what's my total, is adding these two up, which we know is 12,000. It's a very, very small chance of that happening. Okay. So if you want to know, if this is the probability and you want to know for a lot of people how many would be being struck by lightning in this case, you basically just go 1 over 12,000. You multiply the probability times the number of people that are in this case involved. So I will go 1 divided by 12,000 times 850,000. That's 70.83 and then some. You can't have a decimal here because it's people. It's approximately 71 people. Don't worry about D. We don't have to worry about theoretical versus experimental probability. Now, I'm going to ask you to try 9 to 11. I'll post a video that goes over it if you get stuck, okay? Thank you.